All right, so we're filling yet more different shaped containers to see what the rate of change is. Maybe pause the video and have a think about what the graph of the rate of depth, change in depth against change in time would look like for this container. Assuming you've had to think about what might happen, let's go ahead and play and see what's going to happen. As we pour the water in, we're going to get something like this. And then hopefully you realize that as it gets to that point there, the rate of change will increase. So we're going to get a graph that looks something like this. Now let's analyze each part in turn. So this part of the line here is this bottom part of the vessel. So if we look at the change in depth over change in time, we can see that the change in depth was 4 centimeters, and that took 4 seconds. So we can say that the rate of change was 1 centimeter a second for this bottom part of the vessel. And then we can also say that for the next part, we can say this. We went from 4 to 8, so it was 4 seconds again, but the change in depth this time was quicker, or it was larger. So let's say it went all the way up to, it went from 4 up to 16 is up here. So that's a difference of 12. So 12 centimeters on 4 seconds is 3 centimeters a second. So the rate of change increased once we got to this part of the container, which makes sense. You've probably experienced that when you're filling up a bottle. As it gets to the neck of the bottle, the depth increases more quickly and the water shoots out of the top of the container. So yeah, what we have in this situation is we're essentially talking about gradient. The gradient is more shallow here, is less between 0 and 4, and it's larger between 4 and 8. So yeah, the rate of change is increasing, but it's increasing in a disjointed way, unlike in other examples where we sort of have a smooth increase in the rate of change. Here we've got sort of a disjointed increase in the rate of change. The other thing we can say is that, the rate of change is constant in each part. So the rate of change between here and here is constant, and then the rate of change between here and here is constant. And what that means is the gradient of these lines is constant separately. So, between here and here, it's constant, and then between here and here, it's constant. Obviously, they have different gradients, but, in each separate part of the vessel, the gradient is constant. So that means the rate of change is constant. Okay, hopefully that clarifies, yeah, how water would fill in a vessel like this. And yeah, hopefully getting to get a picture of what rates of change are all about.